This is a problem that you will find yourself facing every single day. A straight wire 60 centimeters long is bent into the shape of an L. What is the shortest possible distance between the two ends of the bent wire?
That's right, folks. You guessed it. We're turning this straight wire into an L, a capital L.
We can solve this problem like we would a triangle, using a hypotenuse as the distance between the two sides. Our friend Jordan was kind enough to demonstrate this for us, showing us the effects of different x and y values on the hypotenuse of the triangle.
It appears when the x and y are both equal to 30, we're getting the minimal amount for our hypotenuse.
We're told that we have a 60 centimeter wire, and if we bend it and we have two sides, we can say that the sum of the two sides, which we can call x and y, is 60. If we solve for y, that's 60 minus x. We're looking for the distance between the two endpoints of each side of the wire. We can call the distance between the two endpoints the hypotenuse and set this up as a triangle. Since this is a right angle triangle, we can use the Pythagorean theorem, and we're trying to minimize the hypotenuse. To do so, we must find the critical points, but first we must have the equation in terms of just x. Using what we had earlier, y equals 60 minus x, we can sub that in for y. After substituting y for 60 minus x, we can expand the equation and simplify it, which would make it easier to differentiate later. We can now collect like terms and solve for h. Now that we have the equation solved for h, we can find the derivative using the chain rule and then simplify the derivative. Since we're trying to minimize the hypotenuse, we must find the absolute minimum of the function. To do so, we'll have to find the critical points, which are when the function either equals 0 or does not exist. It may initially look like this function has a restriction in the denominator, but no matter what input for x, the denominator will never equal 0, therefore the function has a domain of all real numbers. However, for this example, the domain is restricted to between 0 and 60 centimeters since that's the length of our wire. We then know that the only critical point is when h prime equals 0, and we can set it at 0 and solve for x. Solving for x gives us 30, which was our prediction from earlier. Our endpoints are 0 and 60, and when x equals either 0 or 60, the hypotenuse equals 60. Therefore, we know that 30 is a minimum and not a maximum. From here, we can solve for y using our 60 minus x equation, and then since we have x and y, we can solve for h using the Pythagorean theorem. H simplifies to 30 times root 2 centimeters, which is approximately 42.4 centimeters. Finding the minimum distance between the endpoints of a wire is an absolutely critical life skill, and now when you're saving the world and you need to find that distance, you'll know that the x and y should be the same.